So this is going to start the graphing linear equations section. So you guys are going to have graphing lines that are in slope-intercept form. That's the one we're going to focus on first today. Tomorrow we'll talk about standard form, and then there's also something called point-slope form. So there are 3 different forms of lines that you guys are going to learn how to graph. And then if everything goes according to plan, we will finish this unit tomorrow, which means Monday you guys will have like a big review to do, and then Tuesday would be your first quiz, okay? None of our quizzes in here are actually all that long, but just one thing I want to mention to you, you guys are allowed to make a page of notes for your quiz. So I usually tell people wait until we go through the review together. So like on Monday, I'll have you work on the review some by yourself, and then we'll go through it. Then I would make a page of notes that night because your quiz is going to look like the review. So I wouldn't try to make a page of notes just yet until you know exactly what's going to be on your quiz. Okay? All right, so when we're graphing linear equations, the first thing we're going to talk about is slope. So this picture here is just a way to remember the different types of slope. If you have a line that is diagonal, like this one, as you look at it from the left side to the right side, notice how it's going uphill. Do you guys notice that? Are you awake? Okay, so if it is going uphill left to right, it will have a positive slope. Okay, so that's important to know. Anytime it slants uphill, our slope is going to be positive. Like that. If you have a line that slants downward, like it's going downhill, like this one over here, downhill means starting from the left going to the right, it decreases. Okay, so you always want to look at your lines from the left side to the right side when I'm talking about uphill, downhill, because some people look at this and they're like, well, this one's going uphill. Well, it is if you're going right to left, but we're talking about left to right, okay? So if you have one slanting downhill, it is going to have a negative slope. So that is your negative. And our slope can be written as whole numbers or fractions. Your slope is never going to be written as a decimal, so that is something that you want to keep in mind. If you have a line like this, just straight across, then your slope is 0. Because slope, I guess I should have mentioned that, slope is basically how steep a line is. So I'm going to write steepness of a line. So if you think about, this floor, if you were to walk straight across the floor, it's not steep at all, it's flat. And so if you have a flat line, like a horizontal line, your slope will be 0 every time. Okay, so all horizontal lines, if I give you a picture of a horizontal line and I say, what's the slope? All of you should be able to tell me 0 because it's flat.
What is that word saying?
This one says horizontal. Then the only other one we have to talk about is this vertical line right here. So the one that goes straight up and down. If you guys think about this, can you walk uphill without help? Yeah? Can you walk downhill? Can you walk straight across? Can you walk straight up and down? No. Like you guys are not able to just go straight up and down if you were trying to walk it. So when you have a vertical line, this is a U, which stands for undefined. UNDEFINED. And I will usually abbreviate it as just UND. So if I ask you the slope of any vertical line, you guys should always respond with undefined. So those are your 4 different types of slope: positive, negative, 0, and undefined. Okay? When you guys are ready, turn that page over, please. We're going to actually find some slope next. And like I told you, a lot of these slides are already filled out, so you need to make sure that you're actually paying attention so you can see where these numbers come from. One of the most important pieces of this is this very first box that I'm drawing. This is our slope formula. Turn that off. If they ask you to find the slope between 2 points and you do not have a picture, like this picture was not there, that's going to be, they're just showing you what it looks like. If all they do is they give you 2 ordered pairs, then we are going to use our slope formula, and slope is represented by the letter M. I know that sounds kind of strange because where does the M come from for slope? But it's some like French word that stands for steepness or something. But anyway, notice how up top they are subtracting the 2 y values. So you guys remember in ordered pairs, it's x comma y. The x value is always the first one in the ordered pair and the y is always the second, just like in the alphabet, x comes before y. But when we're talking about how steep a line is, you actually are going to put the y's on top and we're going to subtract them. So this minus sign will always be there. That's never going to change. I never want to see plus signs. They should always be minus to start with. Okay? And then on the bottom, we're going to subtract our x values. So one of the hardest things to remember when you're going back and forth between ordered pairs and slope is that in an ordered pair, it's x then y. But in slope, the y's go up top and the x's go on the bottom. Okay? Now, if you look at that formula, it says the second y value minus the first y value on top, and then the second x minus the first x. So this is how I always set it up. You will always see me do the y2 minus the y1. So I will always subtract this way because that's what the formula says to do. And then on the bottom, I would take this x value and I would subtract this x value. Okay, so normally you'll see me draw an arrow connecting my 2 y values, and I'll draw that up top as a reminder that those are the 2 numbers that go up top. And then this arrow I tend to draw on the bottom just to remember that those are the 2 numbers that go on the bottom. Okay, you don't have to do that. That's just a way for you guys to remember it. But then there were people last term that every single time they did this problem, instead of going this way, like right to left, they kept asking me, is it okay to do this number minus this one up top and this minus this on the bottom? Yes. As long as you are staying consistent, it doesn't matter if you do y2, then y1 and x2 minus x1, or y1 minus y2 and then x1 minus x2. What you cannot do is go this way on top and this way on the bottom. You have to stay consistent, okay? So when they set this up, here's my second y value, so they put that first. They immediately put this minus sign because that's always there, and then they stuck in the first y value, which was -1. So sometimes you guys are going to have a minus sign and then a negative right next to it, because that subtraction sign is supposed to be there, and then you're just plugging in these numbers. You can't drop this symbol just because there's already a minus sign there. You would just have a minus and then a negative. Same thing on the bottom. They put the 2 first, then they immediately put the minus sign, and then they plugged in the first x, which was also -1. Okay, so do me a favor, pick up those calculators. You need to make sure you understand how to type this in. Once you have it set up on paper, go ahead and type in 3. Then you have to use the minus button, so that's the blue button down the side. And then this button right here is the negative button that's all the way at the bottom of your calculator. So these 2 buttons should not be the same. It's minus -1. And then hit equals, what do you get?
4.
Okay. Make sure you get a +4, because if you don't, you're using the wrong buttons. That's why I want you guys to practice it. What?
I don't think it will give you an answer.
No, do it. See what it does.
So if I did 3 minus,
-1. Mm-hmm.
yeah, it will just go error.
Yeah, it tells you that there's an error. Yeah, so it does at least tell you that you had to have typed something in wrong, but you guys just have to get comfortable knowing the difference between the minus button and the negative button. Okay, go ahead and type in the bottom for me. So this again is the minus and that one's the negative. So make sure you're using 2 different buttons there. And you should end up getting a 3. So you get 4/3. Okay, so the slope is 4/3. And what that means is, if you were to start at this point, which was the -1, hang on, -1 comma -1, that's what this ordered pair is. And then here's the other ordered pair, the 2, 3. A slope of 4/3 means if you start at this point and you go to this point, you would start here, you'd go up 4 and right 3. So that's where the 4/3 comes from. It's up 4, right 3. Both of those are positives, so your whole slope is positive. And if you have a positive slope, remember your line is supposed to be going uphill. So this one is going uphill, so I know that that is correct. With a fraction, since our slope is a fraction, you do have to reduce it if possible. So that's another thing that people tend to struggle with, is 4/3. So if you guys need to have some help reducing, there is a wonderful button on your calculator that says ABC. Do you guys all see that button? This button will actually do reducing for you if you use it. So what you guys would do something for me real quick. Go ahead and type in, hit the number 4, hit the ABC button, and then hit the 3. And it gives you some weird looking answer, right? It gives you 1 1/3. So it gives you a whole number of 1 and then 1/3 as a fraction. Okay, here's the thing. You guys cannot write slope as mixed numbers. They have to be just a numerator and a denominator. So we kind of have to find a different way to let that button do the reducing for us. If we cannot type it in like this, flip it upside down in your calculator. Go ahead and type in 3ABC4 and tell me what it says. So if you type this in as 3/4, it stays 3/4, right? Which means it doesn't reduce. Well, if 3/4 doesn't reduce, will 4/3 reduce? No, because it's the same 2 numbers. Okay, so if you guys ever have a number up top bigger than the bottom, you can use the calculator to reduce it, but you'd have to flip it upside down to see if it reduces, okay? All right, down here at the bottom. This, they didn't even give us 2 ordered pairs here. They're just showing you that if they had given you a picture, so let's pretend you guys had a picture of just this line on your paper. So you didn't see this little triangle they drew out here. If they had just marked this point and they had drawn the line, you can draw in what we call a slope triangle. So that's what they've drawn. They started here, they drew a line straight up and a line over, connecting those 2 points. So this green triangle that I'm coloring in, that's not really part of the graph. I'm just going to use that to count my rise and my run. So I'm going to count how far up did I have to go and how far over did I have to go to get to the other point. So if you guys start counting, look up at the board, please, so you can see. When you start here, this is not 1. When you start counting, you start here, and then as soon as you move up, that's 1. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9. So the whole length of that side is a 9. And then when you get to here and you count to the right, it's 1, 2, 3. So that has, we call it a run. It's rise and run. That has a run of 3. So this is the y, this is the x. That's why they put the 9 up top, the 3 on the bottom. And then, is 9 actually divisible by 3? 9 divided by 3 is 3, isn't it? Okay, so that's why they turned it into a whole number. So the slope here was positive 3. If I told you to write the whole number 3 as a fraction, what number would you put underneath it? Yeah, so if you ever have whole numbers, you guys are always allowed to put 1s on the bottom if you want to write it as a fraction. All right, go ahead and turn the page. Then we're going to start talking about slope-intercept form. Okay, so anytime we want to graph lines, we do prefer slope-intercept form over standard form. So slope-intercept form looks like this. You need to get real comfortable with this. If I say to you over the next couple days, what is slope-intercept form? You need to be able to say it's y equals mx plus b. Okay, so the m represents our slope. And then this letter B here is what we call the y-intercept. So that's where the line would cross the y-axis. Okay, so the good news is that if I tell you, or if I give you an equation like this, so I'm just going to make something up. Y equals 5x plus 2. Let's just say I gave you that equation on a piece of paper. If I ask you right now, which number out of those two is my slope, which one is it? It's the 5, and we know it's the 5 because it has what attached to it? It has the letter x. So whatever number is attached to x, that is your slope. And then if I said to you, okay, what's my y-intercept? It's the positive 2. So if I give you an equation in slope-intercept form, you have a 50-50 shot of getting it right. I'm going to ask you for slope and I'm going to ask you for intercept. The slope is easy to find. Just find x and it's whatever's attached to it. Okay? So down here at the bottom, they've given you an example right here, y equals 2x minus 3. And you'll see they went over here and said, okay, our slope was the 2 because it was attached to x. And the y-intercept this time was negative 3 because it had a minus sign in front of it. Is that okay? They've given you both answers. You just have to tell me which one is which. Even down here at the bottom, y equals negative x plus 2. If you do not see a number in front of a letter, what do we put? Put a 1. Okay? You need that number there because if I say, what's my slope? It's the number attached to x, so that's our negative 1. And then the y-intercept, again, is just that positive 2 at the end. And turn the page. All right, this is the same equation that we were just talking about on the previous page. It's y equals 2x minus 3, but this time they want me to graph it. So first thing I have to do when graphing is I have to identify my slope and I have to identify my y-intercept. So y-intercept, negative 3. I'm going to put a little star there. That is always the number that we are going to plot first. And when we plot it, you're going to plot it on the y-axis. You guys remember which one the y-axis is? It's the vertical. It's the one that goes up and down. The up and down axis, okay? The reason we plot it on the y-axis is because this is the y-intercept. So it wouldn't make sense to plot it on the x if it's the y-intercept. Okay, and then my slope is 2. And whenever we graph, we have to have a numerator and a denominator. So since it was a whole number, see how they stuck the 1 underneath it? Okay, so if I have a positive slope, would 2 be up or down if it's positive? This would be up. And if my bottom number is positive, is that left or right? Right. Okay, so this is literally all you do. It's real simple. We're going to plot the -3 first, and then as soon as I have my dot there, I am going to physically count up 2, right 1, and then I'm going to put a new dot. And then I'm going to go up 2 more, right 1 more, put a new dot. That's all you do. Okay, so if you guys look down here at the bottom, that's what they've done. So they plotted you can't really see this. Let me make sure you guys know that this vertical line, that's my y-axis. They plotted the -3 first, okay? And then once they did that, all we have to do is count. So if you guys can count to like 9, this should be super easy. You're gonna go 1, 2, 1. So I went up 2, right 1, I put a new dot. Now they only did that once. I don't want you to do that once. I want you to do that as many times that'll fit. So once I get here, I would just keep going. I'd say up 2, right 1, new dot. Up 2, right 1, new dot. And I just keep going until I run out of room. So notice when I get up here, I can't go up 2 anymore. So that's the last point I would plot. But then, just for fun, I make you go back to the starting point, and if I can't go up and right anymore, where could I go? Down to left 1, and that'll allow me to have 1 more point. The more points that you plot on each graph, the more accurate your line is. You guys can already look. See how their arrow looks like it's not even going to hit those 2 points? And it's because the person that did this on a computer only used these 2 points. And as soon as you plot 2 points on a computer, the line just appears. But you guys are going to be doing this by hand. So I will want you to plot as many points that actually fit on the graph. Okay, so you can tell theirs doesn't really match up with mine. Mine's going to be the more accurate one. And when we draw lines, a definition of a line, it goes on forever in both directions, so put arrows on each end. I always extend it as far as I can and put arrows. Is that okay so far? Yay. Okay. Like I said, most of these are filled out, so you guys are just going to see different examples, and then we'll actually do some that are blank. All right, this one, the -x plus 2. So again, you'd want to make sure you stuck a number in front of x. If my slope is -1, but we're going to be graphing, I would want a rise and a run, so I would just stick a 1 underneath it. Okay, so now I need you to think for a second. If my top number is negative, is that up or down? It's down. Negative means go down 1. Now the bottom number, see how the bottom number is still positive? Is that going to be left or right? It's going to be right. So all of our positive slopes, we go up right, and all of our negative slopes, we go down right. Notice I have never said the word left. So I don't want you guys to ever say that you're going to go left unless, like, remember here when we ran out of room, then we went back and then we went down and left. That's fine. But to start with, if I ever say, okay, if we have a negative slope, where do we go? It's down right. If I say if we have a positive slope, where do we go? It's upright. Those are your only two that you really have to remember. Okay? Good? Bet you're learning all kinds of stuff about this math on that phone, aren't you? Uh-huh. Yep. It's good stuff right there. The y-intercept is a 2, so we would plot that on the y-axis first. That's the number we're going to plot first. And then once we have our dot there, we're going to just count. Down one, right one, new dot. Down one, right one, new dot. And we'll just keep going till we run out of room. Okay, so here's what this graph looks like. Here's my y-axis, this one here, okay? So if I have to plot the 2 first, they just went up to the 2. So this was our starting point. I know it's kind of hard to see my orange dot there, but this was my starting point. And then because my slope is -1, it's down 1, right 1. So I would count down 1, right 1, new dot. Down 1, right 1, down 1, right 1. Make sure you guys are filling in these extra points because they're not on yours. If any of you guys ever give me a line that looks like this and the arrows are here and here and you've only plotted 2 points, I'm not going to accept it. I'm going to make you redo it. So you might as well just get used to putting all these points on there. It literally just took me 3 seconds. It's not like it takes long. Now that I'm out of room, I would go back to my starting point, and where would we go instead? Up 1, left 1. Yeah. And then up 1, left 1, up 1, left 1, up 1, left 1. Anytime you have a slope of -1 or +1, you can get a lot of points on your graph. And then I know you guys grabbed rulers, so go ahead and extend that line connecting all your points, because that's what you'll have to do on your practice page. Then there's that question at the bottom. It says, does that one actually look like a negative slope? Well, is it going downhill? Yeah, because as you move from the left side to the right side, it is decreasing. So that would be negative. Any questions? Okay. Next page. Have you also noticed that every equation we've done so far starts with the letter y? They've all said y equals. If you haven't noticed that, notice it now. They all have started with y equals. But look at this one. That just says y equals -3. Okay, so first of all, there aren't 2 numbers. There's only 1 number. We need to figure out, is this my slope or is this my intercept? Well, we said slope has to have what attached?
Another letter.
It would have the x attached, right? Does that have an x?
No.
Okay, so that's not my slope, which means it's my y-intercept. Yep, that -3 is the y-intercept. And if there is no x term, couldn't I just stick in a 0x? If there's no x, isn't that 0x? And a slope of 0 looks like what? What? Yeah, a flat line. It's horizontal. So you might want to make this note on your paper. Anytime you have y equals just a number, y equals a constant, it is always going to end up being a horizontal line. Always. You will plot the -3 on the y-axis, and then you're just going to put your ruler down and you're just going to go straight across. So that's what they did at the bottom. This is the only time you only have to plot 1 point. That -3 on the y-axis is right there. And then there's no reason to plot more points because we know it's flat. You have a grid line to follow. So you literally just put your ruler down. I'm just extending this line. And you're just going to draw a horizontal line that goes from edge to edge. Okay, so we have done one that had a positive slope. We did one that had a negative slope. We just did one that was flat, so it had a slope of 0. What's the only one we haven't done yet? The vertical one that's undefined. That's what is on this next page. Tell me what is different about this equation. It says x equals. It no longer says y equals. So the minute you see an equation that starts with x equals, immediately you should say to yourself, well, this has to be vertical because all of the other ones have either been diagonal or horizontal. As soon as it starts with x equals, it is a vertical line every single time, which means we have an undefined slope. So if they tell us x equals 3, would it make sense to plot that on the y-axis if it says x equals that? No. This is the only time you plot on the x-axis. It's the only time. So if you see an equation that says x equals a number, plot it on the x-axis. But that's the only time, okay? So I'm just going to go down here to this picture. When it said x equals 3, I went to my x-axis, which is this one. You would put your first dot at the 3, and then since we already know it's vertical, you don't have to plot any more points. You can just put your ruler down. They extended this one pretty good, so. But you would just put your ruler down and you'd make a vertical line and you'd be done. Are we okay? I don't know what's left. What do we have? I think it's just more examples, right? Yeah, so instead of doing those examples, I mean, you guys can look at them. You have them on your notes. I'm going to give you guys this practice page, and we're going to actually do these 4 problems. You pass those back. You pass yours that way. Okay, make sure you guys are using a pencil, especially when you're graphing, because if you mess up your line and you're using pen, that's going to be a pain. So we actually have one of each type here. Notice number 1 has a positive slope. Number 2 has a negative slope. Number 3 is just y equals a constant, and number 4 is just x equals a constant. So there is one of each type, just like we just finished on our notes. Okay, so for this first one, let's pick out the pieces and then we'll actually do the graphing. What is my slope on number 1? 1/2. So m equals 1/2. And because it's positive, is this going to say upright or downright?
Upright, down.
Upright, because it's positive. You guys always see me I'll either put UR or DR. So when it's positive, here, write that at the top. Positive slope, we're going to go up and then right. And then negative slope, we're going to go down and then right. It's the only 2 things you guys have to remember. Oh no. Okay, sorry. Hey, we have a fire drill in like 4 minutes. So, starting point. I didn't even hear what was said. The y-intercept, I saw it. Y-intercept is -4. That's our starting point. So immediately go to your y-axis. Go ahead and put your first point down here at the -4. And then what we're going to do, starting at that point, count up 1, right 2, put a new dot. And then do it again. And then do it again. I think you can do it twice. Up 1, right 2, up 1, right 2. Now, the good news is we already have 4 points, and 4 points is better than just 2, but I don't know about you guys, but this right here drives me crazy because it's unfinished to me, because I know I can fit at least 1 more point on there, maybe 2. So once I'm done going up and right, go back to your starting point and do the opposite. Go down 1, left 2, down 1, left 2. So you actually can fit a total of 6 points. Put your ruler down, connect them, and make sure you put arrows on each end. For those of you who are new to our building, every term we have to do a fire drill, a tornado drill, and a lockdown drill within the first 2 weeks. It's supposed to rain the next 2 days, so we're doing it today.
That's just amazing.
Okay,
That's truly easy.
the next one. Starting point is still -4. So that is our y-intercept.
Melissa, I have a question. After the fire drill,
We're coming back. Okay, this one right here, it says -x. So what number would I put in front of the x?
1.
Okay, so it's a -1. So my slope has to be written as a fraction. So I'm going to start with a -1, but stick a 1 underneath it. And all negative slopes, where do we go first?
Wait, down.
Down, right. It's either upright or downright, guys. That's all you have to remember. Positive is upright, negative's downright. Okay, so go ahead and plot the -4 right here. And then go ahead and count down 1, right 1, and put a new dot. Do it as many times as you can, which is not much. And then you can switch directions and go down 1, right 1, up 1, left 1. Okay, we need to go. Just leave your stuff. We're coming right back. Back up. All right, make sure you guys have gone down right twice. And then go back to your starting point, go up left. You can do that lots of times. Get this finished. Fill it out. I'm going to collect them. So if you have not done it, you better hurry up and get those first 2 done.
Is it? I have a question. Hey, I only made it as long as I would.
Now the last two are the ones where it's just y equals a constant and x equals a constant. Okay? So the y equals a constant, is that vertical or horizontal?
Vertical? No,
Horizontal? It's the opposite of what you think, because when you think of y, you think this way, but the line goes this way. Okay? So we're still going to plot this on the y-axis. That is still our y-intercept. So you still want to put a point at the 1, but then you don't need any other points. Just pick up your ruler, follow the grid line straight across, and extend it from edge to edge and put arrows. So then the last one that says x equals, this is the special one. When it's x equals, that's the only time this gets plotted on the x-axis because it is the x-intercept. So you want to make sure you go to the x-axis. Your first point goes at the 5. And anytime it's x equals, this is always going to end up being vertical. So you then can just put your ruler down and follow the grid line that's going straight up and down. And when you have all 4 of those done, you need to double check and make sure your name is up there at the top somewhere or at the bottom in all that empty space. And then when you guys get up to turn in your rulers and calculators, just bring me your paper and you are allowed to go. And I will see you tomorrow.